Hello everybody and welcome to the grade 12 test review. That's for the Wednesday test. We're going to do questions 1 through 24 from the final test. Like I said, the next final test, should you decide to take it, will be the same format. And yeah, so check your work, check your head, and then check your questions. You know what I'm saying? Start with number 1. Number 1 is, what is the number of moles in 1.2 grams of sodium? I'm looking for numbers of moles from grams, so I'm going to simply convert from grams to moles. 1.2 grams times, for this I'll need the molar mass. So how many grams are there in 1 mole? By looking at my periodic table, it'll be 22.99. You could also round it to 23. That's going to equal, grams will cancel out. I'm left with moles. 1.2 times 1 is 1.2 divided by 22.99. That will equal, after entering in a calculator, you should get 1.05219. The closest answer to this in number 1 is going to be B. So for number 1, it's B. B says 0.0533. Keep in mind that when we're looking at molar masses, on a periodic table, sometimes we like to round. So whenever you're taking a test and you see a number that's close, you should choose that one that's close. It might not be exact, but if it's only 0.001 off, it's still considered the correct answer. Number 2, for you, how you do? Number of hydrogen atoms in 2.32 grams of methane. Oh boy. There's quite a bit of work here, but to keep in mind something, that you have 4 hydrogens in 1 molecule. I have 4 hydrogens in 1 molecule. Right? So first I need to find out, in 2.32 grams, how many molecules of methane do I even have? Right? And something to remember, do not forget this, is when we have mass, when we're converting, mass can go to moles, which can go to atoms, or molecules. You must follow this pattern, or it can go the other way around. So if I'm starting with grams, that means I have to go to moles, then I can go to the amount of molecules I have. Right? And for this, to calculate this, I need Avogadro's number, which is 6.022 times 10 to the 23. Alright, so let's get started with number 2. And the same thing will be used, the same system will be used in several other questions on this exam. So I have 2.32 grams of CH4 times, I want to first convert it to moles. So in 1 mole, I have carbon is 16, H is 4, those together. I'm sorry, carbon is 12. I was thinking of oxygen. So 12 plus 4 is 16 grams. Grams cancel out. Now I need to get rid of moles. I need to convert that to molecules. Alright, so that times, let's see here, in 1 mole, I have 6.022 times 10 to the 23 molecules. I'm going to put molic for short. Cool. So 2.32 times 6.022 times 10 to the 23 divided by 16. Alright? There's one more step though. In that I need to get rid of molecules because the question is actually asking how many hydrogen atoms. So let's further multiply this out. You can continue writing on the side. I'm running out of space, so I'm going to continue down here. All right, so that's going to be times. Well, if I have molecules here, in one molecule of CH4, one molecule of CH4, how many hydrogens do I have? 4. So 4 hydrogens. That equals something. So now here we have 2.32 times 1 times 6.022 times 10 to the 23 times 4 divided by 16 times 1 times 1. So actually all that divided by 16, which your answer should be 3.493 times 10 to the 23rd. And in this case, both C and D would be your answer. I meant to put C as times 10 to the 24, but did not. So that's how you do number 2. And I hope I'm recording now. I think I am. All right, number 3. Number 3 is the reaction type of this reaction. I have magnesium plus chlorine goes to magnesium chloride. This is a very simple reaction where I'm just taking A plus B goes to A and B. So this is simply a synthesis reaction. Number 4, refer to reaction in question 3. What is the oxidizing agent? And that's it. What is the oxidizing agent? Not what is being oxidized. What is the oxidizing agent? If I look here, my equation will be magnesium plus chlorine gives me MgCl2. All right, magnesium's alone, so it has 0. Chlorine is a diatom, it's 0. Chlorine, if I look at my periodic table, has an oxidation number of -1. So chlorine is -1. Here, though, I have 2 of them, so the total is -2. I only have 1 magnesium that has to be +2 to cancel that out. So magnesium went from 0 to +2. Chlorine went from 0 to -1. All right. So if magnesium went from 0 to +2, it was oxidized, and that means it's my reducing agent. And chlorine went from 0 to -1, which means it was reduced, and therefore it is my oxidizing agent. So the answer for number 4 is D, as in dang. Cool. I'm actually going to leave this up for now, for number 5, because we're staying alive. Beehive. All right, it says, what is the coefficient ratio for the reaction in question 3? This is that reaction. First, we need to find out, is it balanced? Well, I've got 1 magnesium here, 1 magnesium here, 2 chlorine, 2 chlorine. It's balanced. So the coefficient is 1, 1, 1. So the answer here would be D. Number 5 is D. Number 6. What is the molar mass of the product in the reaction from question 3? Well, the product here is going to be magnesium chloride. So, MgCl2. Magnesium is 24.3 grams per mole, and chlorine is 35.4. But if we combine those, it'll be 70.8, which could be roughly rounded to 71. Or if you want to keep the 70.8 for now, that's cool too. So if we add these together, you should get 95.1 grams per mole. And that is number 6. So number 6 is C. As in, can you see how I'm doing this? Number 7, the most difficult question on the test, is really not that bad. I'm using the same equation again. Keep my ratio there because I'll need it. Assume you have 20 grams of magnesium and 41 grams of chlorine reacting together to form magnesium chloride. Which of the following is the limiting reagent? Well, the first step is to balance, which I already did. It's 1 to 1 to 1. So if I have a 1 to 1 ratio, that means that for my reactants, I have to have 1 mole for every 1 mole. They have to be the same amount. So if I look at magnesium, though, I'm telling you I have 20 grams. And it's 24.3 grams. It's 24.3 grams per mole. So how many moles of magnesium do I actually have? On a calculator, you'll see that I only have 0.823 moles. Okay, cool. For chlorine, the question's telling me I have 41 grams. And it's 70.8, or you could have 71 grams per mole. On a calculator, I calculated it based on 71, I rounded, which gave me 0.577 moles. Clearly, this is not 1 to 1, right? So I have a fewer amount of moles than I do of chlorine than I do magnesium. So what is limiting me? What's holding me back? Obviously, it's chlorine. So the answer for number 7 is B. All right. And because this is my limiting reagent, one of my steps was to solve for X, for the moles, all right? So that means that 1X is equal to 0.577. Keep this in mind, because that's how you're going to answer number 8. Regarding question 7, what is the maximum amount of product that can be made? I'm going to keep that in mind. So, my product here is MgCl2. And I'm able to create this many moles of it. So I'm going to have 0.577 moles times the molar mass. So in 1 mole, how many grams are in MgCl2? We calculated that on the front on number 6. So we're going to multiply that by 95.1 grams, and that should give you an answer of 54.87. So that's how much product I'll be able to make. All right. And if I look at number 8, it's definitely not A. It's definitely not B. C is 95. And here I have D at 54.99. That's really close to this number. So depending on rounding, depending on what was expected during the test, this could be the answer. So the answer for number 8 is D. Moving on to number 9, we're still going to keep this equation up. Number 9. It says, regarding question number 7, how much excess do you have of the reactant that was not the limiting reagent? In this case, it was magnesium. Magnesium. All right. But how much of the magnesium did I use? I used this much. So I used 0.577 moles. And in 1 mole, I have 24.3 grams. All right. So the total amount of magnesium that was used is going to be 14 grams. That'll come out to 14 grams. I'm not done yet. My question is, how much do I have left? So I started with 20 grams, but I used 14. So 20 minus 14 grams will equal 6 grams. Now, as you can see here, A, B, C, D, none of those say 6. So the answer is none of these. Cool? Number 10. I'm writing with a fake pen. It's no longer a chicken. We call it a hen. Okay. Number 10. Which of the following group contains 3 oxygen atoms? Dichromate is Cr2O7. It's not that. Phosphate is PO4. It's not that. Sulfate is SO4. It's not that. And carbonate is CO3. It's that. So the answer for 10 is D. Number 11. Which is a monoprotic acid. Even if you had no clue what was going on, you should at least know that mono means one. Assuming you know all the naming, then this should be pretty simple. Sulfuric acid is H2SO4. Right. Sodium hydroxide is NaOH. Nitric acid is HNO3. And phosphoric acid is H3PO4. Now, I already told you in the question, which is a monoprotic acid. So it's definitely not this, because that's sodium hydroxide. The other 3 are acids, even in their names. Well, which one has a 1 proton? 1, mono. Clearly, nitric acid does. So the answer for that is C. Number 12. Number 12. The oxidation number of phosphorus in H2PO4 minus 1 is, so H2PO4, and don't forget I have this minus. So that means that in the end, I have to equal minus 1. That minus there. So from the hydrogen, I'm going to get plus 2. Each one is plus 1, and I have 2 of them, so that means plus 2. Phosphorus is something. And oxygen, each one is minus 2. So that's going to be a total of minus 8. And the grand total will be minus 1. So I have 2 plus something. Plus 8, plus a negative 8 is going to equal minus 1. So we can get rid of this plus because that will be canceled out by the minus. So 2 plus something minus 8 equals negative 1. Right? I hope that you would know that the only logical answer here is 5. So 2 plus 7, or 2 plus 5 is equal to 7. 7 minus 8 is equal to negative 1. So the answer for this is 5, and therefore number 12 is B. Alright, number 13. Number 13 is probably the simplest question on the test. The oxidation number for O2 molecule is, it's a diatom, it's O2, so automatically it's A. It's 0. Number 14, oh boy. It says, which of the following reactions is correct? And by the looks of it, I'm looking at the reaction, and it's saying the oxidation number, oxidation number, oxidation number. Oxidation means charge. So there's that little tool I gave you guys, +1, +2, +3. Whenever you see redox reactions, I would suggest writing this out. It's your life. You don't have to, though. So I have carbon plus sulfuric acid. And also remember, in redox reactions, I don't care about balancing. And that's going to yield CO2 plus SO2 plus H2O. Remember, H2O is H plus and OH minus. Alright, so carbon went from 0 And then over here, it has 2 oxygen. Each one is -2. So carbon one, this is a total of -4. So carbon has to be +4. So carbon is +4. Hydrogen, each one is going to be +1. So the total here is +2. This is -8. Total is -8. So +2 something -8 equals 0 because there's no charge here on the sulfuric acid. So that means it has to be +6. So S went from +6 to something over here. It has 2 oxygen on this side in my products. Each one is -2, so that means -4. So sulfur has to be +4. So sulfur goes to +4. Clearly, thanks guy. Clearly this one went from +6 down to +4. So this was reduced or decreased, and carbon went from oxygen. Carbon went from 0 to +4. It increased. It was oxidized, but it increased. All right. So the question is, let's see, A, it says sulfur oxidation number decreased. That is correct. B, sulfur oxidation number is increased. That is not correct. It went down. C, carbon oxidation number is increased. That is correct. So the answer for 14 is D. Both A and C are correct. All right, moving right along. So now we're on number 15. We're almost done. The rest of these kind of just go with the flow. You know what I'm saying? They're pretty quick. In this, you must remember that in number 15 at least, molarity is equal to moles per liter, or how many liters I have, right? So it says, what is the molarity of a solution of 24 grams of lithium dissolved in 4 liters of solution? I have liters, but I don't have moles. I do have grams though. So again, we're gonna put into play that upside down triangle and go from grams to moles. All right, so I have 24 grams of lithium. I have 24 grams of lithium. I want to convert this to moles. In 1 mole, I have 7 grams. That's going to give me how many moles? It's recording. Recording? Yeah. I'm talking to myself. What do you need?
I need an eraser if you have.
No. I'm so sorry. Thanks for ruining my video. Okay, back to work. We're on number 15. 24 grams. Yeah. So 24 divided by 7. Grams cancel out. Calculating for moles here. How many moles do I have? 3.43. I have 3.43 moles. And it says I have 4 liters. Cool. So molarity is moles per liter. That's going to be 3.43 divided by 4, which should give you 0.857. I'm sorry, 857. I'm going to rewrite that, 0.857. So your answer here for 15 is D. Number 16. The number of moles of aluminum required to react with 1.3 1.31 moles of oxygen is, so it's saying the amount of aluminum, the number of moles that are required to react with 1.31 moles of oxygen. Well, if I look at my ratio, the ratio here is 4 to 3, and for aluminum to oxygen, right? And it's telling me that I have 1.31 moles of oxygen. So that means that the ratio here, if it's 4 to 3, I have to make this also, I have to solve for x. So the way you can do this, as I've told you before, is put the coefficients and assign them to x. So that means that 3x is equal to 1.31. Alright, to get x alone, you'll need to divide both sides by 3. And therefore you'll find that x is equal to 0.4366. Alright. So now to find out how many moles I need over here, I'm just going to take that number and multiply it by 4. And that's going to tell me how many moles I'll need to calculate to react with oxygen. So 4 times 0.4366 equals 1.74. I would need 1.74 moles. Now, that's not A, B, or C. The answer will be D, none of these. So for number 16, the answer is D. Great. Number 17. Number 17, what is the electron configuration for phosphorus? If you look at phosphorus, it is in period 3, right? So I can go through period 1, which is going to be 1s2. Right, it's going to go through the S area in the second period, so that's 2s2. We'll go through the P section on period 2, so that's going to be 2p6. And now we're in the third period. We're going to go past 3s2, and now we're in the 3p area, and I see phosphorus is 1, 2, 3. That's the third end. So if I look at A, it can't be A because it says 3p2 at the end. That's not correct. B, it says 1s2, 2p6. It misses 2s2. It skips over that, so it's not B. If I look at C, I can see that it's the same thing as A, which is not correct. Let's look at D. 1s2, 2s2, 2p6, 3s2, 3p3. Fantastic. So number 17 is D. Number 18. What is the abbreviated version of the element from number 17? Again, phosphorus. This is using the noble gas as a shortcut. So the noble gas before phosphorus is neon. I don't think anybody got this wrong, but in case you did. So it's neon, and then I start from the next period, which happens to be 3. So 3s2 and then 3p3. So the answer here is B. Cool. Number 19, how many grams that are in 0.5 moles of H2? This is a very simple one, but you must consider setting things up correctly. I have 0.5 moles of H2. And I want to convert that to grams. Well, in 1 mole, how many grams do I have? I have 2 hydrogens, so that's 2. I have 2 grams in 1 mole. So 0.5 times 2 is equal to 1. So the answer here is A. Simple, simple, simple. Number 20. How many atoms, oh boy, how many atoms of carbon are in 1 mole of CO2? Well, first of all, 1 mole of anything has Avogadro's number. It's as if I said, how many things are in a dozen? 12. How many things are in 1 mole? 6.022 times 10 to the 23. Cool. So if I had a dozen carbon dioxide, if I had a dozen, that would be 12 times CO2. If I asked you here, if I had a dozen CO2, how many carbons do I have? You would tell me 12 carbons. How many oxygen do I have? You'd tell me 24 oxygen. Right, because I have 2 for each molecule of carbon dioxide. The same principle is going to apply here. Where if I had a dozen carbon dioxide, I would have 12 carbons. Here I'm telling you I have 1 mole of CO2. How many carbon atoms do I have? Immediately you should say the answer is D. But in case you don't see it, it's 1 mole of CO2 times, in 1 mole, I have 6.022 times 10 to the 23 molecules. Okay, and to get rid of moles, we're done. Now I got to get rid of molecules. I want to get to atoms. All right, so in 1 molecule of CO2, how many carbon do I have? I have 1 atom of carbon. Molecules cancel out. I'm left with atoms. 1 times this number, Avogadro's number, times 1 is still this number. So the answer is 6.022 times 10 to the 23. The answer is D. Number 21. Number 21. What is the percent yield of a product you made in lab, assuming your theoretical yield, in theory, was 15 grams, but your actual yield, what you actually got, was only 11.1. This is just like on a test. If somebody said, the total points you could get in theory is 25 points on this test, but you actually only got 13. How would you solve for your percent, your grade? You take what you got divided by what you could have gotten in theory. So in this case, you have your actual divided by your, in theory, what you could have gotten, theoretical. And then you multiply it by 100, if you must, to get your percent yield. So actual is 11.1 grams divided by 15 grams is equal to, times 100. You should have 0.75 times 100, which equals 74, 74%. So the answer for 21 is A. Number 22, how many grams of iron are in 3.4 grams of iron chloride? I guess that would be iron 3 chloride to get the correct name on that one. Cool. So if I have FeCl3, this is 55.8. Cl3 is going to give me 35.4. times 3, which is roughly 106.2. Add these together, and you should get 162. I saw in some of yours you had 161. One person in particular, I won't name who he is, but that's okay. So I have 162 grams per mole for FeCl2. How many moles do I actually have? Because again, the question is how many grams of iron are in 3.4 grams of FeCl3. All right. So let's see how many moles I have first. I have 3.4 grams of iron chloride times, in 1 mole, I have 162 grams. Alright, so that's going to be 3.4 divided by 162, which equals 0.021 moles. Cool. So I have this many moles of iron 3 chloride. Right? So if I look at iron 3 chloride, I only have one iron per molecule, and I have 3 chlorine per molecule. So all you're going to do is you're going to take the number of moles that I have and calculate and multiply by the molar mass, and that should give me how many grams I have of iron. So I have 0.021 moles times 55.8 in 1 mole. Moles cancel. I'm left with grams. Your answer should be 1.176 grams. Hey, the problem is that A, B, C, and D, none of those are 1.176, so none of those are the correct answer. Number 23, I'm only going through 24 on this video. I'll explain 25 in person. Alright, what is the number of grams of NaCl in 300 ml of a 0.18 molar sodium chloride solution? Alright, so that means I have a solution, and my solute is sodium chloride. So I'm saying how many grams do I have? I'm telling you the molarity. So if I have M, molarity is equal to moles over liters. I have this number and I have this number. To get moles alone, I multiply each side by liters. So times liters, let's cancel out, times liters. So liters times molarity equals moles. And once I figure this out, I can convert moles to grams. So liters here is going to be 0.3 liters. All right, you can convert 300 milliliters to liters on your own. I'm sure you guys can do that. If not, let me know. And I'm telling you the molarity is 0.18. So 0.3 times 0.18 is equal to 0.054 moles. I'm not done yet because my question is asking for grams. And I told you here that the molar mass of NaCl is 58.5. Even if I told you it's 78, if a test gives you something, use that. So in this case, I have this many moles times, in 1 mole, I have 58.5 grams. Moles cancel out, so 0.054 times 58.5 will equal 3.159 grams. And that means that B is my answer. So for number 23, the answer is B. Final question, number 24. I'm excited for this. Not because I'm done and I get to move on with my life, but because we're learning. And that's what KBS is all about. It's about learning and growing. as students, teachers, and advancing in the 21st century with technology and transitional leadership. All right. Number 24. What is the concentration? Remember, concentration means molarity of a sodium chloride solution, which is prepared by dissolving 5.83 grams of NaCl in 150 milliliters. So if I'm looking for molarity, I have the amount of liters I need. That's 0.15 liters. But I don't have moles. I have grams. So I need to convert that grams to moles. So let's do it. I have 5.83 grams times in one mole. Getting ahead of myself. In 1 mole, I have 58.5 grams. So 5.83 divided by 58.5 grams are canceled here. I'm left with moles. This should give me 0.0997 moles. And to find molarity, I have to divide that by how many liters I have, which was 0.15 liters. Alright, that should give you 0.664 as your answer, and therefore your answer is A. Have a great day. I hope you enjoyed this. If you have any questions, come to me and say hey. Don't forget to subscribe and like and comment below, and yeah.